wanted to continue with the concept of making solid models as part of equipment design. Traditional mechanical solid models concentrated a lot on how to make mechanical parts ready, generally which refer to the fabrication part, typically machine shop, occasionally about other processes which are related to mass manufacture, including CNC manufacture and so on. In contrast, electrical design or electrical or electronic design automation tools, EDA, concentrated a lot on how to lay out a printed circuit board, or the other way saying in case you have a schematic diagram, how to interconnect all the things as per the necessary interconnections and make sure of what is called signal integrity, saying the signal reaches the intended portion. In that, two very important things are there. One is that from a source to a other destination point or the interconnection point, it is unique, meaning if point A has to be connected to point B, and it should be a specified connection. In the simplest sense, it can be a simple PCB trace by which the 2 points are connected by a small copper trace. That is the simplest things you can talk about. Most complicated is when you have multi layers, meaning you have layer 1, layer 2, layer 3, layer 4. Usually layers in between the layer 2 and 3 can have all the necessary interconnections, and the other two can be ground planes. Alternatively, they can have the ground planes inside and the various circuit elements outside, and this leads to lot of capacitances and what do you call stray parasitic elements. So, EDA tools traditionally have made sure that the interconnection is perfect, including impedance matching, neither loss or unwanted EMI, electromagnetic interference. However, when it comes to our designing front panels and items, we come out with a slightly different consideration. One of the considerations is you still have to have the components which are used everywhere. Now, if you look at my monitor there, you will see lot of these switches. Just have a see here. If you see here, you will notice that one of the first thing is you still have all these physical components. Obviously, one of the important points of this is that though it looks the simplest thing, that just if you say a very simple switch in this case, there are only just two what do you call terminations. In one position they are both connected, another they are not connected. This is about the simplest you can think about. And something which is a little related to this is probably another type of a slide switch, in which you have a center point, and then intuitively we expect that these two are connected in this position, in the other position these two are connected. So, in the old electrical parlance we used to call it a single pole double throw, meaning it has position 1 or and position 2. While it is very easy to talk about it like this and all that, physically when you want to fix it onto an equipment, suddenly you end up with lot of other considerations, and those considerations are often left to another type of a designer, typically what is called a design draftsman. What the design draftsman is, over experience they know what has to be done. So, if you see these two look a little similar. If I see these two switches, nothing very what do you call, nothing great about it, except that as before this has 3 contacts and this has 3 contacts. Now, comes the important point where we can add the value to it by creating certain what we call elemental, just like you have geometric primitives, primitive electronic blocks which are not part of the EDA tools, but are very useful for us when making a electronic design, specifically related to the packaging. So, if you see the left slide switch, while in principle it is similar, the way of mounting it is that there are two small holes here, and probably you need to fix it onto a fascia panel, a front panel or a fascia panel. The moment you fix it to the fascia panel, you end up with the option of how do you take a connection. You see here these terminations here are meant for soldering. So, this one has a small besides the specified width, they had a small hole here, so that depending on your type of wiring and so on, we try to pass a small wire through this and try to solder it. And usually by default all these wires that are used here are insulated wires. A small portion of it is insulation is removed. Typically, if it is the very simplest thing like the usual PVC wires, in short connections and all that, even today it is preferred to have single core PVC insulated. So, you pass the core through that small slot. We have a small slot here. So, the wire is passed through that and you just solder it. While soldering is another technique, you can pick it up in the other design things. In this case, the termination option is very, very important. In the earlier lecture, I showed you how many types of terminations are available. Now, looking back again into this, if you have a large number of them, while it is convenient at one level, another level is the other option here is, you see here we have 3 terminal things which need to be soldered. The advantage of this is here you can use a printed wiring board, and the moment you have a printed wiring board, it is conventional not to stress the circuit, what do you call the contact elements when you operate this thing. Hence, that also 2 more mounting holes are given here. The advantage of these mounting holes is they ensure that once you solder all these things onto a printed wiring board, this is very firm and the stress does not come onto the connections here. See the difference, that one talks about mounting it here and then attaching what do you call some wires here. In this case, automatically these elements go and sit inside a printed wiring board, and both options are there. One of the options you just insert it and then bend it over to make sure that while removing it, it is easier. Alternatively, you can also solder these things. Hence, the metallic load carrying element is made is slightly different from it, and something which is somewhat reasonably related to this is, you will notice that on the printed wiring board itself there are no insulators. The one side of that, depending on the type of this thing, it is generally exposed, but the thing to note here is that those tracks or traces are not going to change. So, once you design a particular spacing, and then once you design a particular what they call conductor width and all that, it stays, and if the manufacturing process is in proper control, these things will stay like that, and their behavior, especially with respect to that parasitic elements, is very much predictable and calculatable. And once upon a time when frequencies were very low, saying the maximum could be maybe 100 kilohertz and all that, there was not much of an issue. But right now, printed circuit boards are being used for 4 gigabytes and even higher, 4 gigahertz and even higher. So, the moment you have these higher things, the layout and calculating the way these electronic circuits work become important. That is why EDA tools have started concentrating on the electrical elements of it. Now, you see while those two are very very real. You see here another small thing has come. In this case, just operating this plunger this way and that way puts it in different conditions, and you see this. Here we have a same thing, probably inside the circuit, inside the layout is probably the same here, except that you have a push button here. Now, the moment you have a push button, the push button has two valid states, one out and one in, and the moment it is in, you need to bring it out. So, you do not pull it out. So, you have a spring and there is a device to take it out. The moment you have a little more complexity has come, saying it is a momentary push button, saying you push it and you release it, or is it a toggling type, meaning if you normally it is in one position, if you press it goes in and stays there, if you press again it will come out like this. Now, in these cases suddenly the device which is visible here, saying do you have a only a plunger is visible. Now, do you have to add a key top to it? You can add a key top, and further what has happened is that the printed wiring board is in this plane. I will loosely I will call it a horizontal plane, while the panel can be here can be in the vertical plane. So, you need to once again you keep coming back saying so many other options are there, and now you see other case. In this case, because that one was a very large device, in this case this is standard key, and here the thing being it is very small. The moment it is small and there is no option for you to have a toggling mechanism, meaning you do not press it and leave it there. There is only one way of operating, it is a momentary on. You press it and release it, follow the move, you just press it and release it. So, usually there will be some way of knowing a feedback where the signal has been the connection has been established, because it does not have a stable on condition. Normally it is one of the things, either normally it is off or normally it is on, and when you press it other thing can happen, and the button itself has the all other things. You can probably have a small square top or a key top, or you can have it exposed. So, if you look back at these things, you see here this one by design has been made to look big, it is big, and the same thing here in this case it has been made a little small, and there seems to be some small opening also here. So, probably a key top option is there, and the same thing these are now available in miniature variants. So, all these type of very large number of things, including what I originally started, are reality in design. You see here, this is slightly different from what I had shown you earlier. In that case, I had shown you printed wiring pads, and in this case the similar switch, but it has soldering provision. And typically all these small things, very rarely their connector is used, directly things are soldered here, and probably these soldered points are mounted on the printed wiring board by some mechanism. Very rarely you have a separate connector and all that. However, when you have large connectors, you end up with the provision of having something which comes to a bulkhead, something here is plugged in, something here is plugged in, and so on, where serviceability and quick change is involved. In this case, most probably the whole subsystem is discarded. While this looks quite easy and nice, when we come to now how do we integrate all these elements, little closer look about the same thing, slightly closer look. This is what I have been showing you earlier, I will just skip it because we have seen it too many times. Now, when we come to such of these devices, these pose a slightly, I will not call it a problem, you need to deal with them slightly differently, because this is not the just what is visible there, what is visible beyond that, this one is the basically the interaction or part of the machine interaction is this displays which comes back, and contrary to our normal what do you call routine this thing, not all the time you have a beautiful flat display which has all those things. There is a, even today they are very expensive. Compared to that, if you use these things like this, several places, imagine those all the small items you have in the house. For example, you have a blender at home, or you have the good old microwave, and then you have let us say a dishwasher and all these things, they continue to have this type of elements. You have seen here, you continue to have this what is called the basic 7 segment display with a dot there. So, dot can be used or need not be used. Generally this sometimes if they are in they are stacked together, they are used as a decimal element. So, the decimal can be on. However, if it is going to be used for a clock application, instead of a single decimal point, you probably have 2 of them, by which that will show the spacing between the hours, minutes and seconds. This is the way these things are wired and the way these things are used is slightly different. The first thing being, since this is being part of the one of the important elements in the front panel, you need to take special care on how do you, where do you locate them, how these are related to the other items and so on. So, I have just given, just like that I have given a search of how many things are available. One of the first things you see is that when it is on, it is bright, it is clear. So, other than the just layout and things about it, 2 or 3 other features are also there, saying you need to probably, when it is dark, you need to dim it, and you can, for the first time you have a way of changing things including the color. So, if you see the latest split ACs, in fact they have gone one step further, they have removed all these things. They don't, no more you have a LED filter glass to allow the light to go in and out. Instead, these are just hidden behind the regular panel, and somewhere in one corner they shine through the case. There the case is made a little smaller, I mean the skin is made a little thinner, and you can see these things easily. Now, whatever the dot and all I have shown you makes sense. Now comes the important point, saying if you now need to attach it to the front panel, you need to now decide on how much of this needs to be shown. Earlier the uninitiated used to just mount a few of them and try to make a small opening of maybe say 15 mm by 35 mm, and you just keep it there and stick a glass, any red acrylic into that. One of the slight problems is, by the time these things, the panel is ready and they are available for you to see, it does not give such a good impression, because if you stack one more, the spacing between this becomes very critical. You have seen both versions are, in this case this is that minute or separator between the things, and this one is the other what do you call, various types of pins and so on. Anyway, you can see all these things. Now, in this case, how do you mount it is also critical. If you remember, I had come back to you earlier and I told you that 0.1 inch is the standard which has been, this pin spacing typically follows 0.1 inches, which is nothing but 2.54 mm. And the way even these case dimensions and all are created, if you just follow the standard way of mounting it, this is exactly whatever the spacing is there, the next half pitch is here. So, you can stack them horizontally. when you stack them horizontally, they read well without any problem. And now comes the important point. Now, when you want to use I will say the mechanical part of design automation, electronic design automation, we need in this case 3 very important things. One of them is that pin, what you call location, or they call it they call it pad or this thing. Then the total footprint, what is the total area it is required, so that you can place it comfortably on the printed wiring board, and the visible portion of it. Now, the moment the visible portion of it comes, we need to now interact between these things, both the front panel layout, then the printed wiring board inside, and tremendous amount of wiring if it is a complicated board. While in our case it is relatively simple, if you take a thing like a new modern camera, next time just randomly go and check on the internet about what is there inside one of these new DSLRs. You will notice that while electronics is very complicated and all that, it is in all places, they are all around, everywhere there are electronics, and these things have to follow based on the ergonomics and based on how the thing is going to look like. So, we see that all these elements need tremendous control. So, at the moment I will just concentrate on how to create a solid model for this. So, we have a device here. Now, if you go to the other this thing here, if you remember, can you please remember this? I started with this saying this is one of the switch elements to show a simple demonstrating device, which will show you how to show what is the difference between binary to decimal demonstrator. This I have shown earlier. So, on a PC it is very easy to do. This is very simple thing. Here what is being done is the top row, these things represent, the top row represents the various type of buttons. In fact, no, the word buttons is used, which is a binary code, and then it is going to display the decimal equivalent for it. So, similar thing I am trying to show you there using common things. In this case, for example, I want to show a number 16. It is very easy. I know by my normal this thing, this is 2 to the power of 1, 2, 3, 4, 5, 6 and all that. So, it starts with first element is what you call 1, then 2, 4, 6, 8 all the way. So, if I press on this, see 16 has displayed. Now, two things are there. Let us say now I want to make 17. I just need to enable the last digit, and you see what has happened here, 16 plus 1 has appeared here, and let us say I need to show 15. I need to remove all these things, and you see the way these things have changed at the bottom. Nothing, it just that somebody is clever enough to make a beautiful flash program, which I have found it useful. So, anybody who is interested in this probably can have a look at it. Now, if we were to make this using a small demonstrating kit like an Arduino or anything, that is where I wanted to show you on the other side. Now, if you go and look at it here, if you remember last time when I left you with this saying, I have here this whole device, I can put it wherever I like. And in this case, I have not set the grid to the 0.1 inches grid, so that very easy for me to copy and paste things. Let us say it is there here, I now copy it. Neat. I have got 6 instances of this. Now comes this thing saying, if you are to fabricate a panel like this here, all I have to do is switch off unwanted things, and I have all the necessary details. In this case, that bottom 4 holes show me the switch mounting, top 4 holes show me the LED which is to be operated. At this point, this is where I wanted to show you. Now, see here, I only picked the openings, but then that whole thing, all the necessary detail including what is the marking that is required, including how the pinout is, all of it comes there in this place. So, it is very easy for us to lay out the front panel by just looking at all the visible portions only, and miraculously the pinout and all that end up here. Now, even if I switch off all these things, I have the pinout drawing. Imagine here at this point I have the display to be added here. So, I am coming back to the original thing what I have told you earlier. What we need to do is make all these things at least at one time, and if you make it modular enough and you make all these layers on and off, you can export and keep these things as elements for a long time. You never need to go back and refer to the manufacturer's catalog, and several of them are directly pin compatible and so on, so that later on down the line 10 years from now, if any servicing is required. So, even for servicing or preparing the manuals and all that, whatever the details you have created can easily be duplicated at that time. And having done this, I have exported this and kept it. Now, I will open another instance using all the information that was available in the other drawing. I have created another component which I will be calling a 7 segment display. Here you have seen 2 or 3 things which I have done. One of the first thing is, other than just creating the things which are available there, one more further thing I have created saying I need to add a bezel and the glass to it. So, here this bezel is slightly bigger than the just the component that was available. Now, this determines how the final equipment is going to look. See that, no, how much extra space and all that. Now, this, it is very easy for me. I have created this, I will now not save it. Okay. I will go and insert it into the thing here, saying I can import it directly from there. See here, that was created at some other place. I am able to import it here directly. Now, it is very easy for me to position it wherever I like, and the have you noticed we have, if I follow the same type of thing which I have used here, I have also the pinout also selected here. Now, the thing is, this particular layer, all other details can be hidden, or at best they can be cleaned up. Once you clean up, this particular pinout drawing can be directly sent or can be opened by any of the standard EDA programs. So, there you have a circuit, you have a schematic capture. After the schematic capture is done, next thing comes in saying you now make the layout. How many elements do you require? In this case, I have just put it exactly in line, so that I have, if you remember earlier lecture I showed you what is called a digi rule. Something equivalent to that, I have a long thing here. On the other side, probably I can have the electronics, or the electronics can be behind. So, I have my small unit which is ready, and the focus in that is that I have made only one instance of the switch and only one instance of the display. Similarly, now if you remember last time when I went here, we have a huge amount of connectors which are typically that so called USB. Standard USB type A is very good and stable and all that. If I now go and check here, allow me to just spend a little time here. I need to please look at it along with you. I will see if I can locate one of these things saying so many of these are available. Seen that very nicely, including we have a very beautiful, the printed wiring board is available directly. The advantage, the way I have been telling you, is it is very easy for you to take any of these what do you call traces here and modify it to do anything you want here. So, if you apply to them, things like this are easily available for us. You have seen this? These things are available. Now, at one corner have you seen this? We have a beautiful, at this corner you have one connector. It seems to be the 9-pin connector. That is exactly the connector which I had taken in the other one. The moment I take these things, it is now, in case I am building a system, when I am building a system, I can just place anything. You see here they have got something called LilyPad. Any of these things, one time if you make them, it is very much possible for you to have tremendous amount of confidence on any of these items you would like to have. You can probably start with prototyping. This is a prototyping board, and once your prototyping board and all is available, even before that you have this, generally we call it a wish board. Wish, you are the one of the earliest people, you can probably try all your things, and eventually when you come to making this of course Uno board, you can now lay all your things wherever you want, and it is very easy for you to have all sorts of these beautiful things which we need to make equipment. Just like in the case of the electronic components, we are talking about the pinout, the area which loosely they call it the what do you call board space or real estate, the amount of space that is required. Similarly, same thing can be used here. In case you want to treat that processor board as a special by itself as a subsystem, you can calculate the, you can make an outline of it minus the dimensions. So, if I now go at this point, I will see whether I can still locate it, saying almost anything you want, it is available here. Now, if the whole thing taken from one of these catalogs, if you can go to the specification, go to the various types of documents. So, you have here I will open the JPEG, you have seen here. Now, if you see here, it is a little like what I was talking to you about, except in this case this is a simple 2D drawing, and critical things they have mentioned here, saying what should be the outside dimension, saying this is approximately some 53 something, and something which is equally interesting is you have seen here they have put mounting holes, there are two mounting holes here, there is a mounting hole here, and they have given also hole at 4 places, diameter is 3.2 mm. So, when you have these things, it is very convenient, and a designer ought to probably convert these things into what I will call electronic primitives, electronic design primitives. Now, you can put all these things wherever you want inside a small enclosure, and you have from a very small subsystem to a really working system you can make. So, I will take a break at this point. The point being, at one level, at the component level, you can have things like all the control elements. Typically, control element can be a simple switch or a push button, and display elements like a very simple LED or a 7-segment display, or a very complicated big mnemonic, or I do not know what they call it, these control stations and all that. You have a huge control station, the whole thing is made as a schematic. It shows where some gas is coming, going everywhere and all that. The whole thing is printed, and then everywhere status is indicated. Such things they operate at the background. They have a probably a huge PLC programmable, and the whole thing, the basic starting element is start with a small 3D what do you call block, which can be moved everywhere, and you need to make this only once. And whenever the pinouts change, the installation the instance I have shown you is the pinouts were directly in the same plane of the front panel. So, it can be in the front panel like this. Otherwise, if it is at a right angle, you need the right angle switches we have made. First you make this, all you need to make it is once you need to make it. Like in the case of display, only one simple 3 segment display I have made. Using those, you can probably build on it and make them much bigger and smaller. So, if you make a something which reads the mains voltage, typically they are called 3.5 digit, because extreme left is usually something very simple will be there. Full things are not needed like this, and the processors and all which have been optimized for that are available. Seen that? So, kindly remember, in our case, in the case of our making electronic enclosures, we try to make each element as a 3D model, and this element has both the things, the mechanical part which is used for making the front panel and all that, the visible or the what do you call aesthetic and functional, the aesthetic element by which you can organize things so that they are error free, and the functional part which shows various operations, and finally the electronic circuit also. So, I mean, I will say this lecture is unique, we are trying to do. Generally they make this and all, wherever the engineers are working, they make it. So, at the moment when you ask for a 3D solid, they generally give you only the physical appearance of it and often without the dimensions. So, at least you can import those things and then add these things, the elements which you would like to have, including, as I said, marking, including things like the various connections and things so on. So, I will stop here. Thank you. I will continue in the next lecture. So, thank you.